Hi, I'm Brian Bedford, and David Durr, Tyler Curry, and myself will be presenting the development proposal for our camera tripod. Over the course of the presentation, we'll cover the background to why we chose the tripod and the transition of parts from the original to the improved version. We'll also go over manufacturing and design for assembly guidelines that pertain to our product. And finally, David will summarize and give our Creo demonstration. Tripods are a common tool for photographers across every discipline within photography, and we looked at different camera brands and found that there wasn't much variance in the way that a tripod's made, which is the initial reason we decided upon choosing the project. For our tripod, we wanted to keep the idea of a standard for the user of the tripod by allowing them to move the camera in many different directions. This slide provides you with two different views of the original design of the tripod. It includes the user-friendly handle that allows movement by the user, as well as the adjustable base that allows the user to manually change the direction of the base. I'll have Tyler talk to you about the individual parts.
In this slide, we will talk about the parts of the assembly. Looking at the front view, starting from left to right, we have the long bolt, which connects the base to the top of the tripod, the control handle that allows you to maneuver the tripod, the base of the head, and the small pressure applying bolt that restricts movement of the top of the tripod. Now looking at a standard view of our assembly, starting from left to right again, we have the top attachment, the insert that goes into the attachment, and the camera mount release function. Lastly, for the parts of the assembly, again starting from left to right, we have the spring, the sleeve bearing, and the long bolt end. The design for assembly analysis. The following DFA guidelines should be considered for the production. The ease of the assembly should be a focal point when designing. Rigid edges can result in tool breakage and a decrease in the stability of the material. You should stray away from materials that might prove to be too dense or hard for given tools. You should have as few operations as possible. Reduce any necessities to as few parts as possible. Make sure the assembly can only occur in the correct way. And since the product is relatively small, avoid parts that can get wedged or are hard to reach. In this slide, you can clearly see the update that we have implemented on the original design. The base of the tripod has decreased in the number of parts required to make this assembly and has increased the mobility of the camera. Here we'll give you a breakdown of the parts of our redesign. We started in our original assembly with 10 parts, and we're able to reduce that down to 5 individual parts. And starting from left to right, we have the rotational ball joint, the rounded base, an updated smaller bolt, an improved camera holder, and an improved top portion of the tripod.
This slide provides us with an example of a manufacturing plan for the improved handle on the improved tripod head. The red lines that we see indicate the tool path that the tool takes when producing the part. This simulation was done using a 3-axis mill. We would also like to point out that we do not believe milling to be the optimal way of producing this handle part or any of the other parts on the improved tripod head. We would suggest that a producer of these parts use either metal injection molding or die casting to produce these parts, as this would offer optimal quality with much more time efficiency and cost effectiveness than milling. Here we have a closer look at the original tripod model. Right off the bat, one can see that this model is quite complex with many different parts. And here we have a closer look at the improved model of the tripod. One can see immediately that there are far fewer parts than the original model. In fact, the number of parts is cut in half from the original to the improved. Furthermore, there's half the number of threaded holes in the improved model as the original model. This leads to faster and easier production, faster and easier assembly, and easier usability for the end user of the product. I will also point out that this would lead to a safer assembly facility, as workers would not be as likely to strain their wrist through the rotational motion of screwing parts together. In summary, the original tripod that we modeled had very little difference from the standard designs that we find on the market today. However, we did not agree that this design was the most cost-effective and efficient design. Therefore, using design for manufacturing and design for assembly, we were able to derive a more stable and advanced model with greater functionality. However, this model still includes the accessibility of the original design and actually provides improved usability to the end user of the product. In conclusion, we truly believe that our product offers more benefits and is easier to produce and assemble than the original design. Thank you for watching.